Hello everyone, welcome to today's video. I just wanted to start off with a quick recap. So yesterday we started to review some of the things in our toolbox, some of the strategies to solve quadratic functions. So I'm going to start with the 3 problems we worked out on our whiteboards yesterday. You can see here for x squared minus 5x minus 30, both factoring and completing the square worked, right? And I kind of like posed the question like, okay, which is the most efficient? Many of you were using completing the square because that's the most recent. Maybe you really like using that pattern. You feel like you've got it down, right? But as we can see, there's a lot more work on the right-hand side for completing the square in comparison to factoring. And then people were like, oh yes, I remember factoring now. Okay, I'm going to try that next, right? And our next set of problems was x squared plus 4x minus 1. But here in this example, you can see that factoring did not work. When we look over here, factoring was impossible because I needed to do like 1 times negative 1. That's how I got this, typo, negative 1 up here, right? And then the middle term, 4x, had to go down here. So I needed 2 numbers that multiply to negative 1, but add up to 4, and there literally is nothing. Because the only way you can get negative 1 is positive 1 times negative 1. Those are the only factors of it. And so if those are the only factors, there's no way you're going to get 4, right? So this was an instance where factoring does not work, but completing the square does, right? Completing the square totally worked. We just got a square root in our answer, which means it's just a decimal, right? But one thing I want you to think about is like when you get whole numbers for factoring or even whole numbers for completing the square, that means you can do it either way, right? You can complete the square or factoring is also valid, right? In the instance where you cannot factor, but you can complete the square, you're going to get some sort of irrational answer, something with a radical, something with a decimal answer that we're not going to be able to figure out if we're looking at just 2 whole numbers, right? The last problem we looked at yesterday was where you can't factor it, and also it is impossible to complete the square. We actually thought like maybe we could, and then I realized as we were talking it out and we were checking our work, completing the square does not work. It looks like it could. It looks like you might have an example of where you cut the thing in half and you get a middle, or you cut the middle term in half and you get a decimal. But check this out, right? So remember, a lot of people were like, okay, 9 cut in half, that's 4.5, 4.5 squared. That's 2025. I'm talking about this step right here, right at the beginning of completing the square. This is valid. This is chill. This is fine, right? But when we go to fill in the box and like actually factor, if you didn't check your work inside the box, that's how I found out that we actually cannot complete the square in this way. Some people tried to. They were so close, but this part right here isn't valid because if you look, we need 5x squared plus 9x. And so if you have 5x squared, 4.5 and 4.5, that's that. 5x squared plus 9x right here. But if you look on the outside, man, right, and I'm going to use, I'll use orange to check, right? 5x times 5x is not 5x squared. It's actually 25x squared. Even further, 5x times 4.5 is not 4.5x. That's crazy. 4.5 times 5x, also not 4.5x. 4.5 times 4.5, that is the only thing that is actually valid, right? Do you see that? That's the only part of this whole thing. This number is the only part that's actually valid. So we cannot complete the square. We cannot try and take the square root of both sides and do like that. We actually did not complete the square. We just like completely made up a different problem. So then I was like, wouldn't it be nice if there was a way to solve it no matter what, right? Because we saw some examples of when like, oh, factoring is better. We saw some examples of when completing the square is better. And we also saw some examples where neither of those worked, right? Enter the chat the quadratic formula, okay? And you might look at this and start to have a panic attack, right? I don't want you to do that. I want you to just take a second and think about, what do you notice about this formula, right? What do you notice about this formula? And more specifically, does anything look familiar? All right, so I hope maybe something that caught your eye was b squared minus 4ac, right? When I was out on Monday and Tuesday, this guy is what we had been working on, and that is called the discriminant, right? The discriminant, which we found out was super easy to do with Desmos and using some sliders, so like what the heck, why not? Something else that a couple people noticed is they were telling me the plus or minus. They've seen that before when we're solving radicals. And then some other people were telling me, they were like, hey, I recognize the radical symbol, right? Like that was really cool too. And we're like, yeah, we actually started out solving by square roots too. And then lastly, somebody told me, they're like, wait, I remember opposite of b over 2a when we were doing standard form, trying to find the vertex and the axis of symmetry. And I was like, wait a minute, this is great, right? So there are tons of this formula that we are actually so familiar with, it's not even funny. So even though it looks really large and super overwhelming, we can totally do this. And so that's what we're going to do today. All right. So you can find today's notes. It's just one page on OneNote. You can take them by hand if you'd like, or you can use a different app if you'd like, or if your iPad is dead, then you should certainly follow along with pen and paper, right? We're only going to get better at the quadratic formula by actually practicing it out. And in this video, we are going to do the ones on the right-hand side of the paper. So the ones with the stars, the example, number 2, number 4, and number 6. So I'm actually not going to go in numbered order. I'm going to start with the example, then we're going to do number 2. You're going to try number 1. I'm going to do number 4. You're going to try number 3. I'm going to do number 6. You're going to try number 5. So that's kind of going to be the order that we're going to go today, just because the ones on the right are a little bit more complex, but then you'll see similar problem on the left-hand side and how you can apply that. So let's go ahead and jump in. At the top of the notes, you'll see that it has our main ideas and our steps for us to take in our very first example. So something I want to draw your attention to straight away is that the quadratic formula is over here on the left. The quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, there are videos out there of people singing songs. I'll play it for you Friday, right? So we're going to use this. And something really, really, really important to know is that the quadratic formula works every single time. Whether your answers are whole numbers, whether your answers have decimals in them, whether your answers have square roots in them, it will solve it every single time. And although it might feel a little hard at first, some of you might actually prefer this method. So just stick with me for a minute. Okay, and essentially there's like 3 steps, but I'm actually going to break it into 4 if that's okay with you. Step 1, make sure your equation is set equal to 0. Very important. Step 1, make sure your equation is set equal to 0. Whoops. Okay, so step 1, still the same. Step 2, also kind of a big deal. You got to make sure that you identify A, B, and C. Before we do anything, we got to make sure we're all on the same page with what's A, the number for A, what is the number for B, what is the number for C. I'm actually going to add in another step right here. It's I'm going to call this step 3, right? Step 3, we're going to find B squared minus 4AC using Desmos, okay? So that's our new step 3. Step 3, find b squared minus 4ac. That's just going to make our calculations a little easier. You'll see that's right here under the radical. And lastly, the true step 4. I'm going to call this not step 3. I'm going to call this step 4, right? Then we're going to substitute all of this into our equation, right? Substitute everything into our equation and simplify, right? And we should get 2 solutions if we get a radical or our discriminant that is bigger than 0. We will get one solution if our discriminant is equal to 0, and we will get no real solutions if our discriminant is less than 0, aka a negative number. For today's example specifically, we are only going to be dealing with 2 solutions just to start and get us comfortable with the quadratic formula. So let's hop into it. Our first example, x squared minus 5x minus 36 is equal to 0. Look at our step-by-step. Step 1, make sure the equation is set equal to 0 and written in standard form. Our equation is set equal to 0. X squared is first, x is next, the number is last. That is standard form, so check. We are good to go. Step 2, we need to figure out what a, b, and c is. So a is the number in front of x squared, that's 1. B is the number in front of x, that's minus 5. C is the constant term, or just the number, negative 36. I'm already halfway done. Step 2, identify A, B, and C. A, B, C. Straight up slay. Step 3 is to find out b squared minus 4ac. And this is just like we did using Desmos. I encourage you to do that as well. So you're going to notice that I am going to split screen it up, and you should do the same. I'm going to grab Desmos, and you'll notice that I pre-typed in b squared minus 4ac for myself, and we're going to add all the sliders in, and we're just going to adjust them based on what we said a, b, and c was. So we can see a is equal to 1, b is actually going to be negative 5 for our example, so I'm going to change that to negative 5, and c is negative 36. We can see that b squared minus 4ac is 169. So I want you to write that down, 169. So again, step 3 that I made was find b squared minus 4ac. Use Desmos for it. This number. Okay. I want to slide this over for a sec. Whoa. So recap, make sure it's in standard form and set equal to 0. Yes. Step 2, find ABC. Yes. Step 3, find your discriminant, b squared minus 4ac. Yes. Now step 4, we're ready to substitute and figure out what our 2 answers are going to be. So x is equal to, if I look over at my quadratic formula over here, it is equal to the opposite of b plus or minus the square root of my discriminant all over 2 times a. So sometimes I like to just put the parentheses of what I'm going to plug in. I actually could just do this too if I really wanted to. And I'm ready to substitute. So opposite of b. B goes right in here, negative 5. This number, 169, goes right in here, my discriminant. All divided by 2 times a. A was 1. Boom. I'm almost done. I just need to simplify this expression. So I get a negative times a negative. If I'm looking at this part right here, negative times negative 5, or opposite of negative 5 is positive 5, plus or minus the square root of 169. That is a perfect square, right? The square root of 169 is 13, all divided by 2. Awesome. And now we know that there's just 2 possibilities for us to solve. There's 5 plus 13 over 2, and there's 5 minus 13 over 2. And when I simplify 5 plus 13 divided by 2, that's 13, 14, 15, 16, 17, 18 divided by 2. Right, that's 18 over 2. That's actually 9. Okay, and 5 minus 13 over 2, that's negative 8 over 2. That simplifies to negative 4. So you can see how after I substitute everything in to like the B, the A, right, this part right over here, and then your discriminant goes right underneath the radical, it's actually not too terrible. And what seemed like a terrifying thing is actually pretty okay, right? It's actually pretty okay. So let's just keep practicing it so that we can start to get better, right? And we'll see a couple of different variations of this, but it's still going to be these same 4 steps. Make sure you have it in standard form and everything's equal to 0. Figure out what a, b, and c is. Find b squared minus 4ac, and then plug it all in and simplify to figure out what we get. So the next problem we're going to do is example number 2. Example number 2, okay? Now mine looks a little different than you because I wanted to make sure I had a lot of space to write my work. But remember, I also have a secret step 3. Find b squared minus 4ac. And what you think is step 3 is actually step 4. Substitute. Okay, so problem 2. 2x squared plus 7x plus 3 equals 12. We can see that the equation is not equal to 0, so we've got to do that. Drop a line. This 12, buddy, you got to go. See ya. Wouldn't want to be ya. Numbers with numbers, x's with x's, x squareds with x squareds. Remember that analogy of going to the candy aisle and there's Skittles and there's M&Ms and there's gummy bears and they all have to go in the right spot? Same idea. Now I get 2x squared plus 7x, and then I have to do positive 3 take away 12, and that's going to be minus 9 equals 0. Once I have done this, right, make sure the equation is equal to 0 and in standard form, I'm ready to move on to step 2. Figure out what a, b, and c is. A is 2, b is 7, c is negative 9. So far, so good. Step 2 is done. Check. Step 3, let's find our discriminant. B squared minus 4ac. We're going to use Desmos because I have a, b, and c right here. It should be pretty easy for me to figure this guy out. So let's go. So we've got a is 2. So I'm going to go over here, zoom out. Whoa. Zoom out a little bit. I'm going to change it from 1 to 2. B is 7, positive 7. So I'm going to type in 7. C is negative 9. And would you look at that? Oops. My discriminant is 121. Right? 121. That's pretty cool. So b squared minus 4ac is 121. Nice. Step 3, complete. Find b squared minus 4ac. I got it, right? Find b squared minus 4ac. Done. Now I'm ready to actually plug it into the quadratic formula, which really, I'm like plugging in 3 separate types of values. I'm going to get rid of this. Okay. If you want, I'll kind of sing you the jingle to remember the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac. All over 2a, right? And we're ready to substitute b and a. B on the top, a on the bottom. B, we look at our ABC is 7, a is 2. Now we're ready to just like simplify it up, right? So this becomes negative 7 plus or minus, oh my God, 121, right? That is a perfect square as well. 11 times 11 is 121. All divided by 2 times 2 gives me 4. Once I have the plus and minus, I can split it into 2 situations. Negative 7 plus 11 over 4 and negative 7 minus 11 over 4. I just need to simplify these fractions. Negative 7 plus 11, that's going to be 4 over 4, which reduces to 1. Negative 7 minus 11, that's negative 18 over 4, which I could reduce that fraction, but I bet money you guys don't want to do that. So, hey, let's Desmos it up, right? Like negative 18 divided by 4. Negative 18 divided by 4, and let's get a decimal. Negative 4.5. Cool, right? Negative 4.5. By these 2 answers alone, right? By figuring these out right here, negative 4.5 and 1. Because of the 4.5, this guy would not have been factorable. You could probably complete the square, but it was not going to be factorable. So like quadratic formula is already flexing on us, right? Okay, so what I would like you to do, use this example, number 2, and I want you to try number 1. Okay, so you're going to try number 1, x squared minus 8x equals 20. Okay, hey, just want to give you a hint. This is your first step. Do you end up, once, check your work, see if this was your first step, x squared minus 8x minus 20 is equal to 0. Now that you've done this, make sure your equation is set equal to 0 and written in standard form. Now you're ready to go to step 2. Okay? All right, so hopefully you solved this problem and you got 10 and negative 2, right? Step 1, make sure the equation is set equal to 0 and write it in standard form. Gotcha. Step 2, find A, B, C. A is 1, B is negative 8, C is negative 20. Step 3, which should be right here, is find B squared minus 4AC. Using decimals, you would get 144. And then lastly, step 4 would be substitute and simplify. So plugging it in here, and your discriminant, and simplifying, you would get 10 and negative 2. Okay, so again, my turn to kind of walk you through another iteration. It's really just these same steps over and over and over again, I promise you. Find B squared minus 4AC is really secretly step 3. And lastly, step 4 is plug it in to the quadratic formula. Okay, so this is kind of similar to problems 1 and 2 that we did together, where there is a little bit of subtraction involved, but the thing we're subtracting is different. So let's just jump into it. Number 4, doing this together. Make sure your equation is set equal to 0, right? Currently not equal to 0, right? We have this over here. It's got to go away, right? But like mathematically go away. I can't just like ignore it, right? So we're going to get rid of them. Like, hey, whatever you do on one side, do to the other. It is currently positive 6. So the opposite of positive 6 is minus 6. And there was an x with it, so we got to take the x. Whatever you do to one side, you do to the other. X's with x's, so I'm going to write it right under 15x. I'm not going to put it under x squared, but I'm going to combine these terms. That leaves me with x squared. 15 take away 6 is 9x. And there's no constant term, so I could write plus 0 equals 0, or a lot of times people just leave it like this. Step 1, complete. Make sure it's equal to 0 and written in standard form. Check. Step 2 was to figure out what the heck A, B, and C is. So let's do it. A is 1, B is 9, and you guessed it, C, there's nothing here for C. That's where C normally is. C is 0. Step 2, done. If I messed up step 2, that could totally affect step 3, finding your discriminant, B squared minus 4AC. But luckily, as long as I'm writing out everything where it's supposed to go, as long as I'm putting everything actually in standard form, I should be good. So again, we're going to go to Desmos. We know A is 1, so let's change that. A is 1. B is positive 9, and C is 0. So we'll just delete that and change it to 0. You can see that, B squared minus 4AC is giving us 81, with B is 9, C is 0, A is 1. So 81, another perfect square. Pro tip, right now for today, and just for today right now, I'm choosing examples where the discriminant is a perfect square. It's not always a perfect square, but just for our intro, day 1, I wanted to make sure it was like the numbers were nice. Now we're ready to substitute into the quadratic formula. X is equal to opposite of b plus or minus the square root of my discriminant all over 2 times a. So opposite of b was 9, a was 1. Boom, I just pop them in there, right? Plugging these guys in right here and right here into my quadratic formula. I'm plugging in right here, and you know what this guy is already. 81 was my discriminant. Now I'm ready to simplify. Negative 9 is just negative 9 plus or minus the square root of 81. I know the square root of 81. It's positive 9 and negative 9, but hey friends, the plus or minus is already there, so you can just leave it as 9. All divided by 2 times 1, which is just 2. Now I'm ready to split this in to 2 answers. Negative 9 plus 9 over 2, and negative 9 minus 9 over 2. Negative 9 plus 9 is 0 over 2. That's just 0. Negative 9 minus 9 is negative 18 divided by 2. That's negative 9. Not too shabby, not too bad, right? I finished it. I was able to get my 2 solutions. Now that we've done problem 4, I'd like you to try problem 3. Hint, one of A, B, or C is 0. Make sure you're careful in figuring out which one it is. And we'll come back and see if you're right. Okay, when you set this guy up, step 1 is done for you, right? Step 1, make sure your equation's equal to 0. Done. Step 2 was the hint, the tricky part. Did you make sure that b is 0? There is nothing with an x term. There's nothing right here in the middle. Then when you find b squared minus 4ac, you get 144. When you substitute it into your quadratic formula, opposite of b, opposite of 0, plus or minus square root of 144, all divided by 2 times a. A was 3. And you'll simplify your values to getting 0 plus or minus 12 over 6. So you got 0 plus 12 over 6 or 0 minus 12 over 6, and you ended up getting positive 2 and negative 2. All right, let's keep it going. I got one more example for us to do together and one more example for you to try. Stick in there, hang on. I know it's been kind of a long one, but just trust, okay? Just trust, stick with me. All right, I'm gonna do number 6. 4x squared plus 9x equals 12x. First things first, we need to make sure the equation is equal to 0, and right now, she ain't. Because there's this guy over here. You got to go mathematically. See you later, alligator. I'm going to take away 12x. Whatever I do on one side, I do to the other, and I line them up. The x squareds would have to be together, right? And this currently just has x, so that's not going to work. The x's have to line up, and then the numbers have to line up too. So keep that in mind. When I simplify this, you're gone. This becomes 4x squared. 9 take away 12 is minus 3x, and I get equals 0. Step 1, complete. Step 2, figure out A, B, and C. A is 4, B is negative 3, C, there is nothing over here, so C is 0. All right, find A, B, and C. Perfect. Next step, figure out what b squared minus 4ac is in Desmos, right? B squared minus 4ac. Let's see. Split it. Pull it. B squared, B was negative 3 minus 3. C was 0, slay. A was 4. You can see that b squared minus 4ac is 9. Cool. It's 9, which is great. That's a perfect square. This is step 3. B squared minus 4ac, that's 9. Now I'm ready to plug in to my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, which we found out was 9, all over 2 times a. Right, a was 4, b was negative 3. I just substitute them in right here and right here, substitute, and now I'm ready to simplify. Negative negative 3. A negative times a negative gives me positive 3. Plus or minus 9. It's a perfect square root. That's 3 all over 2 times 4, which is 8. So I have 3 plus 3 over 8, or 3 minus 3 over 8. Again, just to be super clear, the plus comes from this part. The minus comes from this part. Something else that I should probably bring up, make sure you're being extra careful. I'm sure y'all are, especially when like b is negative, for how you type in b squared minus 4ac to Desmos. You notice that b squared has parentheses around it. That's in case b is negative, which it was in this instance. So make sure you are careful about that. Now I just need to simplify this. 3 plus 3 is 9. 9 over 8. You can leave it as this fraction if you want. You could reduce this to 3 over 4 if you want. Or if you're like, nah, dude, this is not for me. 9 over 8 in a calculator is 0.75. Again, since I have a decimal, immediately not factorable. 3 minus 3 over 8 is 0. It's okay to have 0 on top. I get 0. Okay, here's your last example. Would you please try to solve x squared minus 10x minus 21 equals 0? Step 1 is already done for you. Let's rock and roll, and let's come back and see if you get the correct answer. All right, guys, did you get -7 and -3? I hope so. Step 1, make sure your equation is set equal to 0. Was already handled for you. Here we were. Step 2, find a, b, and c. You did. Step 3, which is right here in between, find b squared minus 4ac. This little guy right here. Used Desmos, got 16. Step 4, substitute and simplify. Opposite of b over 2a, plug in that discriminant. You would get 10 plus or minus 4 over minus 2. Careful about that. Then you just simplify it up and you should get hopefully -7 and -3. All right, guys, I'm going to cut the video right now because it's probably, I'm looking at like 32, 33 minutes, and that's not accounting for you taking notes. When I see you tomorrow in class, we're going to keep practicing problems. And yeah, and then we'll probably have some delta practice over the weekend. So I will see you in class. Bring any questions. And remember that this video is also posted on YouTube. So you should rewatch it if you need to, if you need a little refresher. But yeah, have a great day. I'll see ya on Friday.